The object I recorded for Lab 1 was a car driving down the street at a steady velocity. Then, using Tracker, I was able to find the position of the car over time from the video, and from that, I was able to find the velocity. In the observed model, the velocity is not quite constant. In fact, over time, the car appears to accelerate slightly. My GlowScript model shows a range of velocities from 1.7 meters per second to 2.5 meters per second. And as you can see here on the graph, that compares the expected versus observed position of the car at a constant velocity. It should follow the orange line on the graph at 17 meters per second. However, the blue line is what I observed from Tracker. Potential user error could affect this, like the Tracker system not being exact with the vectors that were measured, or the other thing that could contribute was the driver of the car was not going at a steady pace to begin with. To address the questions in Lab 1, first, if the axes were flipped, the result would be the exact same. However, the position vector would just be in the y direction instead of the x direction, meaning that the object we observed would have a direct velocity, or a constant velocity directly upwards. To answer the second question, a non-zero net force is required to change the velocity of an object, and since this video was intended to be of an object with constant velocity, it would make sense that the net force can be set to 0 in the GlowScript model, or else the velocity would be changing due to a net force. In total, I'd estimate that there were 5 net forces, or 5 pushes and pulls on the car. The first being the initial push, the gas on the car to move the car forward to a constant velocity. The other forces would be the force of gravity, and in return, the earth pushing up on the car. And then in the left direction would be air resistance and also friction.